Hi everyone, welcome to this video. Today we're going to have a look at sketching graphs under a horizontal translation. So to start off with, we've got a equation y equals square root of 2 cos x take pi on 4. And we want to eventually graph this function. Before we start off with anything else, looking at this bit here, this is what's going to cause or make our horizontal translation. So if we instead graph the function the square root of 2 cos x first, we can then use this function and just have a horizontal translation. So let's look at this first and then we'll have a look at the whole function. So from here we can have an amplitude, and an amplitude is going to be the number multiplying the trig function, in this case square root 2. Like before, our period is going to be 2 pi on n. In this case, we've got 1, so it's just 2 pi. And we don't have a vertical translation, so our center or equilibrium point is at 0. So we can also look at our range, so our maximum and minimum. We start at 0, we go up square root 2, we also go below. So we get plus and minus square root 2 for our range. We're now going to sketch this, and if I can actually draw straight lines. Between 0 and 2 pi. We've got a cos function, so it's going to look something similar to that. So hopefully something like that. And we want to label some of these points to use our horizontal translation. So our first one, we start at the positive square root 2, because that's our maximum. Down here, it's halfway, so we're at pi. So this is going to be pi negative square root 2. In here, it's halfway between 0 and pi, so we've got pi on 2. And here, we're going to have 3 pi on 2. Our final point is at 2 pi square root 2. So that's the function for square root 2 cos x. Now we can use this to be able to sketch this one. So underneath, I will draw that. So 0 to 2 pi. Now, essentially what all these points do, or what this does, is moves it either left or right. Because it's negative, we're going to have a translation to the right. So basically we take all these numbers here. So this one here will move to the right pi on 4 units. And this one here will move itself to the right pi on 4. And same thing for this one, and for this one, and for this one. And so what we'll end up having is all these points which we can use to sketch the new function. So my maximum point here is going to be still at square root 2 because I haven't moved up, but it is now at pi on 4. So that's the coordinates of that first point. It's moved across. This second point here, we have pi on 2 plus pi on 4. So think of it as 2 pi on 4 plus pi on 4 will be 3 pi on 4. So that point moves across. To 3 pi on 4. Our minimum point now moves across. We had pi and we add pi on 4. So that's going to be 5 pi on 4. So here's pi, here's 5 pi on 4. So that's going to be our minimum point now. And this one here, we started as 3 pi on 2. We're adding pi on 4. So 6 pi on 4 plus pi on 4 is 7 pi on 4. I'll start drawing in the graph just so we can see what's happening so far. Now this point here has moved out beyond 2 pi. So let's work with that. So that would be 8 pi on 2, on 4. I might just, go with that. Okay, so that's what it would roughly look like. It's just taking that shape and we've moved it across. However, we only want it between 0 and 2 pi. So that means I need to cut it off at this spot here, and I need to fill in the rest here. So basically the pattern continues. It's just that we're going to have a intercept somewhere over here. So I can get rid of that bit there. So I don't need any of that. And I do add on this extra bit there. So that's how we essentially sketch these graphs with the horizontal translation. Just start with your basic graph and then translate it either left or right. If that was a positive pi on 4, we'd be moving to the left instead of the right. So I'm going to leave that here for now. In the next bit, we'll have a look at part B. So part B, we've given a equation minus 2 sine 4x plus pi on 3 plus 5. And we want to work out what the amplitude is, the period, and the range, and any phase shifts. So to start off with, I just want to rearrange this equation. So we still have minus 2 sine, except instead of 4x plus pi on 3, I'm going to have 4 out as a factor. So 4x plus, if I take 4 as a factor of pi on 3, I'm left with pi on 12. Okay, 4 times pi on 12 gives me pi on 3. So I'm just doing that and then plus 5. The reason we do that is because this indicates we've got a phase shift, and this gives us a dilation. So we need it in this form, not in this one here. Amplitude is, as usual, well, just 2. Period is now 2 pi on n. In this case, n is going to be our 4, because it's the multiplier. inside the trig function. In this case, it would be pi on 2. Our range, we've got a vertical translation of positive 5. So we're going to have plus 5 plus 2, or 5 take 2, so either side of 5. So we get 7 and 3. We've now got a phase shift as well of pi on 12 units. And that's all that we need to do. So from this, I could use this information to sketch this graph like we did before, but we're just looking at the amplitude, period, and range at this stage. That's it for now. Thanks for watching.